Uranus, the seventh planet from our Sun, is a true giant of our solar system. A world of ice and gas, it dwarfs our own planet significantly. To truly grasp its scale, imagine this. Earth could fit inside Uranus 63 times over. This icy giant spins on its side, a unique characteristic in our solar system. Astronomers theorize a massive collision early in its life knocked Uranus onto its side. Its discovery in 1781 by William Herschel ushered in a new era of astronomy. Uranus, much like its fellow gas giant Saturn, boasts a magnificent system of rings. The true spectacle lies in the retinue of moons that orbit this icy giant. 27 moons, each more intriguing than the last, dance around Uranus. These celestial bodies are named after characters from the works of William Shakespeare and Alexander Pope. Titania and Oberon, the king and queen of the fairies in Shakespeare's A Midsummer Night's Dream, lend their names to the two largest moons. Among these fascinating moons, Oberon stands out. Its surface, scarred by ancient impacts, tells a tale of a violent past. Oberon's dark, reddish surface hints at the presence of organic molecules, the building blocks of life as we know it. What secrets does this distant world hold? Join me as we embark on a journey to uncover the mysteries of Oberon. Imagine the night sky before the invention of telescopes. Our ancestors, gazing up at the stars, could only see the celestial objects visible to the naked eye. The invention of the telescope in the 17th century shattered this limited view. Galileo's observations of Jupiter's moons revolutionized our understanding of the solar system. No longer was Earth the center of all creation. The telescope became the key, unlocking the secrets of the cosmos. This newfound ability to peer deeper into space led to a cascade of discoveries. Among the pioneers of this new age of astronomy was William Herschel. In 1781, while surveying the constellation Gemini, Herschel stumbled upon an object that would change our understanding of the solar system forever. The newly discovered planet was named Uranus, after the Greek god of the sky. Little did Herschel know that Uranus held another secret, a retinue of moons. On January 11, 1787, Herschel discovered two of Uranus's largest moons, Titania and Oberon. These celestial companions were the first moons to be discovered orbiting Uranus. In 1986, Voyager 2 made its closest approach to Uranus. Voyager 2's cameras captured Oberon's heavily cratered surface in stunning detail. Vast plains of ice stretched across its surface, interspersed with towering mountains and deep canyons. These observations provided crucial clues about the moon's formation and its violent past. Imagine holding a basketball in your hand. That basketball represents the Earth. Now picture a softball next to it. That's Oberon. Oberon measures about 950 miles across, just a fraction of Earth's size. Despite its relatively small size, Oberon is still a significant celestial body. Its mass, composed primarily of ice and rock, exerts a gravitational pull strong enough to maintain its hold on a very thin, tenuous atmosphere. Unlike the rocky, terrestrial planets like Earth and Mars, Oberon is a world dominated by ice. Scientists believe that beneath the moon's heavily cratered crust lies a vast subsurface ocean. This hidden ocean is kept in a liquid state by the heat generated from Oberon's interior and the gravitational tug of Uranus. The presence of this subsurface ocean raises intriguing possibilities for the potential habitability of Oberon. Further exploration of this enigmatic moon is crucial to unraveling the secrets locked beneath its icy shell. Imagine a cosmic dance between a giant planet and its moon, their gravitational forces locked in a delicate balance. This intricate dance is what governs Oberon's orbit around Uranus. The constant stretching and squeezing caused by these forces generate heat within the moon's interior. This delicate balance is essential for understanding the complex processes that have shaped Oberon over billions of years. At first glance, Oberon might appear as a dull grey world. But look closer, and you'll discover a surprising palette of colors. The most prominent color on Oberon is a dark reddish-brown hue. This reddish tint is thought to be caused by the presence of tholins, complex organic molecules. These subtle variations in color offer a glimpse into the complex history of Oberon. Imagine a world untouched by the eroding forces of wind and water. This is Oberon, a celestial time capsule preserving the history of our solar system's tumultuous early years. Its surface, a canvas of craters, chasms, and mysterious mountains, tells a story of cosmic collisions and geological upheaval. Each crater on Oberon's surface is a window into the past. The sheer density of craters suggests a long and violent past. Amidst the craters and chasms lie hints of internal activity, suggesting that this distant moon may harbor a surprising level of geological complexity. Craters, the most prominent features on Oberon's surface, come in a vast array of sizes and shapes, each telling a unique story about the impact that created it. Some craters appear as simple bowl-shaped depressions, while others boast complex structures with central peaks, terraced walls, and extensive ejecta blankets. One of the most striking craters on Oberon is Hamlet, a massive impact scar spanning over 120 miles in diameter. Named after the tragic hero of Shakespeare's play, Hamlet's size hints at a cataclysmic event, a collision with an asteroid or comet of significant size. The impact that created Hamlet would have released enormous amounts of energy, melting and vaporizing ice, fracturing the moon's crust, and ejecting vast plumes of debris into space. Another notable crater is Othello, a large, well-preserved impact basin with a diameter of about 60 miles. Othello's most striking feature is its dark, smooth floor, which contrasts sharply with the surrounding heavily cratered terrain. Scientists believe that this dark material may be composed of impact melt, molten rock and ice that solidified shortly after the impact. By studying the characteristics of craters like Hamlet and Othello, scientists can estimate the age of Oberon's surface. The more craters a surface has, the older it is, as it has had more time to accumulate impacts. Based on crater counts, Oberon's surface is estimated to be several billion years old, indicating that it has been relatively unchanged since the early days of the solar system. Section 3. Chasmata Scars of Ancient Upheaval. While craters dominate Oberon's landscape, they are not the only features that tell a story of its past. Cutting across the moon's surface are long, linear features known as chasmata or grabens. These chasmata are essentially giant cracks in Oberon's icy crust, some extending for hundreds of miles. Scientists believe that these chasmata formed as a result of tectonic stresses within Oberon's crust. These stresses could have been caused by a variety of factors, such as the moon's cooling and contraction, tidal forces from Uranus, or even the impact events that created Oberon's craters. As the crust stretched and pulled apart, it fractured along lines of weakness, creating the chasmata we see today. One of the most prominent chasmata on Oberon is Mormor Chasma, a massive rift valley that stretches for over 370 miles across the moon's surface. Mormor Chasma's sheer size and depth suggest a significant period of tectonic activity in Oberon's past, indicating that this icy moon may have been more geologically active than previously thought. The presence of chasmata on Oberon provides valuable clues about the moon's internal structure and evolution. By studying the orientation, distribution, and morphology of these features, scientists can learn about the stresses that shaped Oberon's crust and the processes that have molded its surface over billions of years. Section 4. The Mystery of Oberon's Mountain. Amidst the craters and chasmata, there lies a particularly intriguing feature that has puzzled scientists since its discovery. A solitary, unnamed mountain rising abruptly from Oberon's surface. This mountain, captured in a single image by Voyager 2, stands out against the surrounding plains like a lone sentinel, its origin and composition shrouded in mystery. Estimated to be several miles high, the mountain's isolation and unusual shape have sparked numerous theories about its formation. Some scientists speculate that the mountain may be a central peak that formed within a massive impact basin, similar to the central peaks seen in craters like Hamlet. However, no such impact basin has been identified in the vicinity of the mountain. Another possibility is that the mountain is a cryovolcano, a type of volcano that erupts volatile compounds like water, ammonia, or methane instead of molten rock. Cryovolcanism has been observed on other icy moons in the outer solar system, such as Enceladus and Triton, and it is possible that Oberon may harbor similar activity. The mystery of Oberon's mountain serves as a potent reminder of how much we still have to learn about this distant world. Further exploration, with higher resolution imaging and perhaps even a dedicated mission to Oberon, is needed to unravel the secrets of this enigmatic feature and shed light on the moon's complex geological history. Section 1. Voyager 2. A Fleeting Glance. Our current understanding of Oberon is largely based on a single encounter, a fleeting glimpse captured by a robotic emissary from Earth. In 1986, Voyager 2, a NASA spacecraft on a grand tour of the outer solar system, made its closest approach to Uranus, providing us with our first detailed views of Oberon and its fellow Uranian moons. Voyager 2's flyby of Oberon was a fleeting encounter, a cosmic rendezvous lasting only a few hours. Yet, in those precious few hours, the spacecraft's instruments beamed back a treasure trove of data that revolutionized our understanding of this distant moon. Images captured by Voyager 2 revealed a world far more complex than anyone had imagined, a surface scarred by ancient impacts, etched with canyons and chasms, and harboring a mysterious solitary mountain. Voyager 2's instruments went beyond simply capturing images. They measured Oberon's size, mass, and density, providing clues about its internal composition. Spectroscopic analysis of the reflected sunlight revealed the presence of water ice, organic molecules, and hints of other ices on Oberon's surface. While Voyager 2's flyby of Oberon was a remarkable feat of engineering and exploration, it only provided a tantalizing glimpse of this enigmatic moon. The spacecraft's trajectory and limited time for observation left many questions unanswered, mysteries waiting to be unraveled by future missions. Despite the limitations of a single flyby, scientists have continued to glean valuable information about Oberon from Earth-based observations and by analyzing the data collected by Voyager 2. These remote observations, though lacking the detail of a close encounter, have provided further insights into Oberon's composition, surface properties, and potential for harboring a subsurface ocean. One technique used to study Oberon from afar is spectroscopy, which involves analyzing the light reflected from its surface. By studying the wavelengths of light absorbed and reflected by different materials, scientists can identify the chemical compounds present on Oberon's surface. These observations have confirmed the presence of water ice, as well as organic molecules that may hold clues to the early solar system's composition. Another technique is occultation, which involves observing a celestial body as it passes in front of a star. By measuring the changes in the starlight as it passes through or is blocked by the object, scientists can learn about its size, shape, and even the presence of an atmosphere. While Oberon's atmosphere is too thin to be detected directly, occultation observations have helped refine our understanding of its size and orbit. Though Earth-based observations and data analysis provide valuable insights, they are limited by the vast distance between Earth and Oberon. To truly unlock the secrets of this enigmatic moon, we need to send a dedicated mission, equipped with advanced instruments capable of probing its depths and unraveling its mysteries. The exploration of Oberon, like any celestial body in our solar system, hinges on a complex interplay of scientific curiosity, technological advancements, and funding priorities. While no dedicated missions to Oberon are currently planned, several concepts and proposals have been put forth, each offering a unique opportunity to delve deeper into the mysteries of this icy moon. One such concept involves a Uranus orbiter and probe mission, similar in scope to the Cassini-Huygens mission that revolutionized our understanding of Saturn and its moons. A Uranus orbiter could spend years studying the ice giant and its system of rings and moons, providing detailed observations of Oberon's surface, mapping its gravity field, and searching for signs of a subsurface ocean. Another concept focuses on sending a swarm of small, low-cost spacecraft to Uranus and its moons. These CubeSats, equipped with miniaturized instruments, could be deployed to study Oberon's surface composition, magnetic field, and interaction with Uranus's magnetosphere. The technological challenges of sending a mission to such a distant and harsh environment are significant. However, the scientific rewards of exploring Oberon, a pristine example of an icy moon in the outer solar system, are immense. By studying Oberon, we can gain a better understanding of the processes that shaped our solar system, the potential for life beyond Earth, and the incredible diversity of worlds that exist beyond our own. We've journeyed far, from the discovery of Uranus to the detailed examination of its moon, Oberon. Once just a faint point of light in Herschel's telescope, Oberon has revealed itself to be a complex and intriguing world. Its heavily cratered surface speaks volumes about a tumultuous past, shaped by cosmic collisions that dominated the early solar system. The chasms that scar its landscape hint at internal forces, possibly tectonic activity, that have sculpted its icy crust over billions of years. While we've gleaned valuable knowledge from Voyager 2's flyby and Earth-based observations, Oberon's true nature remains shrouded in mystery. Does a vast, subsurface ocean lie hidden beneath its icy shell, potentially harboring the ingredients for life? What secrets does the solitary, unnamed mountain hold, standing as a silent testament to our limited understanding of this distant world? These unanswered questions beckon us to explore further, to unravel the mysteries that Oberon holds within its icy embrace. Oberon's significance extends beyond its own intriguing characteristics. As we explore the vast expanse of our solar system, we find that icy moons like Oberon are not uncommon. In fact, they may be some of the most common types of worlds orbiting gas giants. Studying Oberon, therefore, provides a window into a class of celestial bodies that may hold clues to the formation and evolution of planetary systems throughout the cosmos. The exploration of Oberon is not merely an academic pursuit. It's a testament to humanity's innate curiosity and our unyielding desire to understand our place in the universe. Each mission we send, every observation we make, every piece of data we analyze brings us one step closer to unraveling the cosmos's grand tapestry. Oberon, a sentinel in the distant Uranian system, reminds us that our solar system is teeming with unexplored frontiers, each holding the potential for groundbreaking discoveries. As we develop new technologies and push the boundaries of space exploration, we can look forward to a future where missions dedicated to studying Oberon and other icy moons become a reality. These future missions will undoubtedly reveal new wonders, challenge our assumptions, and inspire generations to come. They will provide us with a deeper appreciation for the sheer diversity of worlds that exist beyond our own and the intricate processes that have shaped our solar system and countless others scattered throughout the universe. The universe beckons, inviting us to explore its mysteries and uncover its hidden truths. Oberon, with its captivating allure and unanswered questions, stands as a symbol of the endless possibilities that await us as we venture further into the great cosmic unknown.